मोल क्या होता है, उसकी हमें ज़रूरत क्यों पड़ती है, और साथ उसके जो बाकी रिलेशनशिप है अवोगाड्रोस नंबर के साथ वो हम कैसे फाइंड आउट करते हैं. व्हाट इज द मोल? लेट्स स्टार्ट. मोल. अच्छा, लेट मी टेल यू why we need mole. अच्छा, scientists say that in a full stop, not this one, the full stop which is found in your books, okay, the full stop. So that full stop contains 2 million atoms. 2 million atoms means 20 lakh atoms. Means you have to divide this full stop. This is not that one full stop into 20 lakh particles, into 20 lakh parts, and one part will be equal to atom. So you can understand how small an atom is. So it cannot be made in grams. It cannot be made even in the milligrams. It's very small. So it can be just compared with another element, with another atom of the element. So here we take relative atomic masses, means we take the carbon as a standard to compare other atoms of the elements with it, and in this we get relative atomic masses. Okay. So here we are. Let's suppose I have an element. Suppose it's sodium. Its atomic mass, means by comparing it with the carbon, okay, we considering the carbon 12 and comparing with the carbon, it has 23 mass, and that will be in AMU. It's very small. It's for one atom of the sodium, okay. And for the molecule of water H2O, this is atom of an element. This is the molecule, and it has 18 AMU. For an ionic compound, okay, so we use the formula unit. For the formula unit, we have 58.5 AMU. So this is just for one formula unit. This is AMU just for one molecule. This is for one atom of the sodium. But in chemistry labs and in the laboratories, we cannot take out one sodium atom. We cannot take out one sodium atom, okay, because it is very difficult. So we have to use a bulk quantity, a huge amount, okay, but with accuracy. So in this way, all the atomic masses, molecular masses, and formula masses, atomic masses of the atoms of the elements, molecular masses of the molecules, and formula masses of the ionic compounds, whatever their masses are expressed in grams. Means we increase their values, we make them huge by just putting gram, are expressed in gram. So let's consider them in gram, so that we may use them in the laboratories, okay, so that we may use them in the laboratories for doing the different experiments. So that's why I'm going to tell you that we convert this 23 AMU into 23 gram, okay. So in the same way, 18 AMU into 18 grams and 58.5 AMU into 58.5 grams. And whenever we convert these atomic masses into grams, molecular mass into gram, and formula unit mass into grams, they are called 1 mole. They are called 1 mole. 1 mole. This is also 1 mole of that substance. Understood? So it means we can say when atomic masses, molecular masses, and formula masses, or whatever the masses are expressed in gram, so it is called 1 mole. So what is the Avogadro's number? Means we were saying that 23 AMU has one. This is the mass of one atom, but which is very difficult for us to calculate. This is the relative atomic mass, relative molecular mass for one molecule of water. This is for one formula unit of sodium chloride. So we have increased into grams, so it is called 1 mole. So how many atoms this much grams have? How many molecules this much grams have? How many formula units this will have? So actually these are equal to 1 mole, so we will call it that 1 mole of any substance is equal to 6.02 multiplied 10 raised to 23. As we call it, 1 dozen is equal to 12. Whenever we go to market, we buy something and we say, I need 2 dozen, so he will give us 24. If I say I need 1 dozen, he will give me 12. In the same way, whenever we say 1 mole, it means 6.02 multiplied 10 raised to 23. This is the constant fact. Okay, so 1 dozen, as we say 1 dozen as 1000 is equal to 12. Okay, in the same way 1 mole is equal to 6.02 multiplied by 10 raised to 23. Actually, this quantity was given by a scientist whose name is Avogadro, so that's why this is called Avogadro's number. So we represent it like this. Okay, if we write here small a, so it means sodium, but this is for capital for Avogadro's number. Okay, so it is equal to 6.02 multiplied by 10 raised to 23. It's a huge amount. It's a huge amount. Okay, I think it's enough to find out moles and Avogadro's number. Okay, to know about the moles and Avogadro's number. Okay, so before we go ahead and we are going to study the topic stoichiometry. Okay, so before we go into depth and we start stoichiometry, we need to know some special things about the stoichiometry. Okay, so I'm going to write here the topic stoichiometry. Some people say stoichiometry. Okay, so this is a Greek word. Actually, this is about all the molar calculations. Okay, I will define it too. But before we go into depth, I would like to tell you some formulas that how would we calculate the moles. Okay, so these are very important to know. Formulas. First, for moles, mole is equal to given mass divided by molar mass. Molar mass, the mass of 1 mole of any substance. Okay. And if we have to find the given mass, we can rearrange it. Given mass is equal to mole multiply molar mass. 1, 2. Third formula is, if we have to find out the particles, mean number of atoms. Someone asked number of atoms, number of molecules, number of the formula units, number of ions. Whenever there is used number of, so it means there is something like something fishy, means you have to use here Avogadro's number. Okay, so number of particles, I am going to summarize. I am going to summarize all of these number of molecules, atoms and ions just into one word, that is particle. Number of particles. Number of particles is equal to given mass over molar mass multiplied by Avogadro's number, means 6.02 multiplied by 10 raised to 23. Okay, so here if you will be given only given mass. Okay, you can write given mass and molar mass we have to find ourselves, and then this will be Avogadro's number, we know it well, and in this we will find the number of particles. But if we are given the number of particles and we have to find the given mass, so we will rearrange this equation as we arranged the first equation and to make the second equation. In the same way, third equation can also be rearranged to make the fourth equation. So I am going to write here given mass will be equal to number of particles. This molar mass is dividing, so it will be multiplied on the other side. Molar mass. And that Avogadro's number is being multiplied with given mass, but when we have to shift here, so it will be divided by all of this. Okay, is it clear? So fifth is when we have number of particles and we have to find the moles. Here we are finding the moles from given mass. So here we are going to find the moles from given particles divided by Avogadro's number. But when you are given the moles and you are set to find out the given particles, then you rearrange it. What you write? Given particles is equal to moles multiplied by Avogadro's number. Okay, so these are 6 for molar calculations. Still we are not going to discuss the stoichiometry. Stoichiometry we can also find by the ratio method. Okay, that is very easy method and very accepted method, well accepted method in all over the world. So we use the ratio method, but here we have this stoichiometry. We have this molar calculation. For a basic calculation, we need to know these formulas, and after that, I am going to tell you about the stoichiometry. Okay. Okay, welcome back to stoichiometry. Welcome back to chemistry, and we are going to discuss the stoichiometry. What is stoichiometry? Actually, I would like to define it first, and then we'll go towards its examples. Okay. Stoichiometry. What is stoichiometry? Okay. Stoichiometry is a branch of chemistry. Okay, which tells if we know the reactants, if we know the moles of the reactants, and the next which are found on the products, we can find the moles of products from balanced chemical equation. Means we are given the standard which is called the balanced chemical equation. So in balanced chemical equation, we can find out reactant to products and from products to reactants. We can find out mass of the reactants to mass of products. We can find out mass of reactants to the moles of products. We can find out the mass from the mass of the reactants to the volume of the products. Or reactant to reactant. If we are given two reactants, we know about the, because we are given the standard by knowing about that standard, which means the balanced chemical equation, we can find out from one reactant to another reactant. So I am going to tell you here, it's the quantitative relationship. Quantitative relationship between reactants and products. Quantitative means which can be quantified, which can be given the quantity, which can be calculated, which can be measured. So this is the type of relationship between the reactants and products. It can be among the reactants, it can be among the products, it can be from reactant to products, mostly from reactant to products. But one more thing is that it has to be in balanced chemical equation. In balanced chemical equation. There are three types of calculation we can do, and we'll do one by one. Okay, let's take it. First is mass to mass ratio. Mass to mass calculation, you can say. If we know the mass of one substance, we can find the mass of another. How? Let's do it. We have H2 plus O2 given H2 H2O. Here we have two oxygen atoms because it can be taken in the molecular form, it cannot be taken alone. So that's why to make it double, I can't write here 2 because it will become H2O2. So I have to write here 2. So in this way, hydrogen will also increase. So I am writing here 2. Is it okay? Now let's see. This is a balanced chemical equation. Now suppose we are given a quantity, a mass, that you have 64 gram of oxygen. Okay, and you have this in enough amount. So how much will be the mass of water will be found from 64 gram? So this will be mass to mass by ratio method. Mostly accepted as ratio method. We know oxygen has 16 mass, and for 2 atoms it will be 32 gram. Okay? We know water has 18, and for 2 it will have 36 gram. Means when we use 32 gram of oxygen, we get 36 gram of water. Okay, of course hydrogen is also used, but just I want to tell you that if 32 gram of oxygen is used, so then 36 gram of water will be formed. But if we have 64 gram of oxygen and we have this in enough amount, okay, so 64 gram of oxygen, then how much mass of this water will be formed? Means this is the standard. Means we can say oxygen ratio water from this equation. 32 gram of oxygen makes 36 gram of water. If we have 64 gram of oxygen, what will be this water form? X. Cross multiplication, 32x is equal to 64 multiply 36, okay, and x will be equal to 64 multiply 36 divided by 32, 1 time, 2 time, and it will be 72 grams. So this is the mass to mass calculation. Means if we know the mass of one substance, we can find the mass of another substance in the stoichiometry. But we need to know first balanced chemical equation. Now I am going to tell you about the second thing, which is the mass to volume calculation. Here we have second calculation, mass to mole calculation. Mass to mole calculation. The same equation we are going to take for our own use to understand it properly. Okay, we have 2H2 plus O2 give rise to 2H2O. Is it clear? So now you can see the same mass we are given, 64 gram. What is 64 gram? We are given 64 grams. So now someone asked that you are given 64 gram of oxygen, find out the moles of water. Moles of water. Okay. So first we have to convert this given mass into the moles. Okay. We know that oxygen has molar mass 32. So given mass by molar mass 32 gram per mole. Gram will be cancelled the gram, per mole will become the mole, and 1 time and 2 times. So it will be 2 mole. By ratio method, we find out the moles of water. So how we find by ratio method? Oxygen ratio water. It has 1 mole. From here it has 1 mole. We don't write here, but we consider it 1, okay? And it has 2 moles. And when we have 2 moles of this, what will be this? Cross multiplication, x will be equal to 2 multiplied 2 means is equal to 4. So 4 mole of water will be formed. So here we are, that we have done that we were given the 64 gram of oxygen, and we calculated from 64 gram first the moles of oxygen, and then we compared from moles of oxygen to the moles of water, and we found the moles of water. Means mass to mole calculation. We were given the mass and we found the moles of water. Okay, by converting this mass into moles and then mole to mole ratio. Is it clear? So next is mass to volume ratio. Okay, so next one is, sorry, this is third one. We are going to find mass to volume calculation. Mass to volume calculation means if we are given the mass of the reactant, then we can find the volume of the product. Suppose I am going to write a different equation which I never wrote in the first two, but I am writing out carbon plus oxygen, and we get carbon dioxide. This is the solid, this is gas, and the carbon dioxide is also gas. So if we are given that you have 18 gram of carbon, then what will be the volume of the carbon dioxide produced? Volume. So first we need to convert this 18 gram into the moles, and then we compare the moles of carbon with the moles of carbon dioxide. So it has mass 12 gram per mole. Okay, so it will become 1.5 mole. Okay, given gram will be crossed with gram and per mole will become mole. So if we have carbon 1.5 mole, so by comparing carbon with the carbon dioxide, means 1 mole of carbon give rise to 1 mole of carbon dioxide, and 1.5 mole of the carbon will give rise to how many? So by cross multiplication, x is equal to 1.5 multiplied by 1 is 1.5. So here we have calculated its moles first, which is equal to 1.5. Now we need to know volume, and we know what is the molar volume. Molar volume means the volume occupied by the 1 mole of gas. This is just for gases. Okay, so 1 mole of gas at STP, standard temperature pressure, occupies 24 dm3. Okay, it varies in different syllabuses, but in a international level it is 24 dm. Okay, so if 1 mole is equal to, means 1 mole ratio, we find mole ratio volume. If 1 mole is there, then 24 dm3 will be there volume, and if we have 1.5 mole, then what will be the volume X? So X is equal to 1.5 multiplied 24, so we will get X is equal to 36 dm3. Again, I am going to explain it. Mass to volume calculation. Mass to volume calculation means we were given the mass of one substance. We converted mass into its moles. We compare the moles of one reactant with the product. Okay, we found the mole of the product, and after calculating the moles of the product, we found the volume of the product by this method, means mole ratio volume. So 1 mole is equal to 24 dm3, and when we have 1.5 dm3, sorry 1.5 moles, so what will be the volume of that gas? So by unity method, we found that X is equal to 1.5 multiplied 24, and it becomes 36 dm3. So here we started from the mass and we found the volume of the substance. So this was the third calculation which we have done. So in this way we can carry on the stoichiometry calculations, and this is the simplest method which I have explained.